Hello everyone, today we're going to be going over the Blind 75 in C++, and today we're working with the problem minimum window substring. Now, before we get started, before we break down every single problem, make sure we have these 4 questions already laid out in order for us to be able to help dissect and break down the problem. We first need to figure out exactly what the input's going to be, what data structure / algorithm / technique to use, what to do with the data, and finally what our output is going to be. Again, feel free to pause the video if you're following along to be able to write out these comments accordingly, and we're going to go through step by step on how to solve this problem. So, breaking down the question, given 2 strings s and t of lengths m and n respectively, so we already know what our input is, return the minimum window substring of s such that every character in t, including duplicates, is included in the window. Okay. If there is no such substring, return an empty string. Okay, so we know our input and our output, and if we were to go about based on the example, so it looks like we have this entire string s and this string at t, and we notice that the output is going to be b, a, and c, where we can find that over here. So this substring has all the characters from this string alone, and it even says in the example, the minimum window substring b, a, and c includes a, b, and c from string t. And we can probably do the same thing for a and a. The output's a, the entire string is s, is the minimum window, and then if the input of a and then t, in this edge case, both a's from t must be included in the window, since the largest window of s only has one a, and we return an empty string. Okay, so those are some things to be able to keep in mind. Now, mind you, since we are dealing with 2 strings, in particular, the technique that we'll be doing is going to be the sliding window technique. I'll have a visual on the side to be able to help illustrate the idea that we're trying to construct for the solution. With the sliding window technique, we will create 2 maps to keep track of the frequencies of our characters, including duplicates. And maps, basically the best way of visualizing them is that they have a key value pair type of relationship, where maps are like lockers in particular and keys. There's a specific data element that we keep track of in order to actually access another data type. So that's the scope really of how maps are seen visually, just giving a metaphor on that. So we will use the maps to indicate what has been visited and the frequency of each character. And the steps for us to be able to create the sliding window technique for this problem are going to be as follows. Step 1. Actually, I will also put it up here. We need to find the substring of s that includes all the letters from t. So the steps for us to be able to solve this particular problem are going to be as follows. Step 1, we're going to initialize 2 pointers, left and right, at the beginning of string s. Step 2, we're going to initialize 2 frequency maps called frequency s and frequency t to store the count of the characters in s and t, and we're going to create a variable counter to keep track of the number of characters from t that are missing in the current window, and we are going to create variables min, length, and start index to track the minimum window length and the starting index of the minimum window substring, then add the frequency of characters from t to frequency t. And I understand this is a bit of a long problem, so what I'm going to do is just break this up. We have really 11 steps to be able to go over, so I'm going to write out step 1, step 2, step 3, And step 4 to help follow along and break up the whole type of problem. So step 1, we're going to create our frequency maps. So the way we do that, maps. That's actually step 2. Step 1, we're going to create 2 pointers, left and right, at the beginning of the string s. So the way it's going to look, int left is equal to 0, int right is going to be equal to 0 to initialize. And then step 2, we're going to create 2 frequency maps to store frequency and how many and the characters we visited. So we're going to call this unordered map character int and then frequency s. And then we will have the same for t. Then for step 3, we're going to create a variable counter to keep track of all the characters from t that are visited. So counter equals t.length. And then for step 4, we're going to create variables min length and start index to track the minimum window length and the start index of the minimum window substring. So I know that's kind of a lot. So the way we're going to do this is int min length, and this is how we initialize our minimum length. Int start index equals 0. This is just how we created. And then what we will be doing for step 5 is that we will scan. And then this part is going to add the frequency. So I'm going to make this for A. Then add the frequency of the characters from T to frequency T. The way it's going to be done is going to look like for character CH for T. And we're going to add the characters in the frequency of T. Then we will have to move over to step 5, which will be scanning through our array until, hang on, you know what? So I'm going to divide this up into 2 parts. So we will need to focus on our right pointer, and then we'll focus on our left pointer. And then return the substring in s from start index with the length of min length. So step 5, when we're focusing on the right pointer, is that we're going to scan through our array until the right pointer has reached the end of our string s. Then step 6, if the character current position at the right is present in T, we're going to decrement the count for frequency of T, and if the count becomes 0, we're going to decrement the counter until we have our output set in place where everything becomes 0, and we're going to have an edge case for step 8 later on for the left pointer. Is 0. That'll be for step 8. So for step 7, what we'll do then is we're going to move the right pointer to the next position, and then we're going to move over to step 8. Focusing on the left pointer, while the counter is 0, all characters from T are found in the current window. And then we're going to update the min length and start index if the current window length is smaller. Then while we're inside of this while loop, if the character at the left is present in t, we're going to increment its count in frequency t, and if the count becomes positive, we're going to increment the counter. Step 10, it's going to move the left pointer to the next position. And then for our output, this is entirely for step 11, the substring s from return the substring in s from start index and length of the min length. All right, so to be able to go and focus on the right pointer, so steps 5, 6, all right, here we go. We can scan through the array relative to our s length. This will be, in fact, we are going to, all of this entirely will be inside of our while loop that we have. So 5, 6, 7, 8, 9, and 10, aside from 11, are going to all be inside of our while loop that we will create. So, just going to try to get the structure right to be able to help you folks understand and see clearly how this logic will work. So, for step 5, what we're going to be doing is that we're going to scan our right pointer, right, and it's going to be less than s.length. Then, step 10, we will do this. For step 6, if the frequency of t count relative to s right what we'll do is that we will, if the character's current position at the right is present in t, at the right pointer, decrement the count for the frequency of t. So the way it's going to look like is we're going to have frequency of t s right, and then decrement. Then if the frequency of t is going to have the s right, hang on, greater than or equal to 0. We're going to decrement our counter. Then remove the right pointer to the next position. In step 8, while the count is 0, the current counter is 0, so the way we do this is that we will have while counter is equal to 0, all the characters from t are found in the current window. If so, the way it's going to look like, right minus left is less than the min length. And we're going to update our min length, right minus left, and the start index to be the left. In step 9, if the character at the left position is present in t, so if frequency of t dot count s left, then we are going to increment frequency of t relative to s left, increment that. If the frequency of t s of left is greater than 0, we're going to increment, hang on, let's count in frequency t, and if the count becomes positive, not position. If the count becomes positive, okay. Sorry if there was some confusion over here. If the frequency of left is 0, then we're going to increment our counter. And for step 10, we're going to increment our left. Just make sure, okay. Yeah, so we have a bracket misplacement over here. No, this bracket should be first. Yep, there we go. And then finally for our output, which will be step 11, the way it's going to look, return the substring s from start index with the length of the min length. Should be over here. So step 11 is going to look like this. Return. Just going to put this over here for the sake of clarity. Return the min length, which is equal to int max empty string or the substring with the start index relative to the min length. Okay. Let me just double check to see if it's all correct. Just gonna run this. Bit of a syntax error that we have. Didn't capitalize on this. I am sorry for the syntax errors that I'm getting. Alright, steps. No parentheses over here. No. No. Okay, it passes all the test cases, and again, I'm going to have this all in the comment section as well, so you folks can also follow along at the same time. So let me submit this, and actually let me clean this up so that way you folks can see the entire solution, and then I explain the space and time complexity as well. Again, all this will be in the comment section down below. All right. Come on. There we go. Okay, cool. There we got that. So This is what it should look like. Let me just double check. Okay, submit this. Okay, now to just give a rundown on space and time complexity for a following solution, since our space complexity is pretty efficient for this. The time complexity for a solution is going to be O of n, where n is the length of string s, and we traverse s with 2 pointers, and in the worst case scenario, we traverse the string twice. Well, meanwhile, the space complexity is O of m, where m is the number of distinct characters in t, and we use 2 frequency maps, frequency s and frequency t, to store the count of characters. In the worst case scenario, if t could have all distinct characters, we're going to lead O of m space complexity. So yes, this was minimum window substring. Thanks again for taking the time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put them in the comment section. And as always, take care. Cheers. Bye-bye.